Okay, so today we are going to learn two more ways of proving triangles are congruent, or triangles are equal to each other. The first one that we're going to do is angle side angle. Again, just like before, since it has ASA, that means I have two pairs of angles equal and one pair of sides equal. And we need to have the side in between the two angles that are equal. So just like in here, here are my two angles that are equal, and this is the side that is between the angles that is equal, so that would make it angle side angle because the side's between the angles. So with the first one, again, attack it the same way. Go first, I have my given. AP is equal to PD, and angle A and angle D are right angles. Again, it's my given statement. And so the second thing, so I've got AP is equal to PD, so AP, single line through, PD, single line through. Go through my written given statement, so angle A and angle D are right angles. So again, I've got it marked on my picture already that they're right angles. So if angle A and angle D are both right angles, I know that angle A is equal to angle D. I can put this by definition of right angles. Then the last thing, again, I've used all my written given statements, so I can look at my picture. My picture looks like a bow tie, so I have vertical angles. So I'm going to say that these two angles are equal to each other. So if I'm naming this angle right here, I would name it like I write it, which would be BPA. So angle BPA is equal to, the other angle I could name DPC. Angle DPC. By vertical angle theorem. And so again, make sure that we understand, I've got three things equal. I've got a segment, and I've got two angles. So once I have my three things that are equal to each other, then I can say my triangles are congruent. So I can say triangle BAP is equal to triangle CDP. And so again, if I look at my picture, these are my angles that I have equal, and this is the side that's between the angles. So I would say that they are equal by angle side angle, because it's the side that is in between the two angles. With the next one down, on the bottom, again, same thing. So I'm going to go through. First thing is that E is the midpoint of AD. And angle A is equal to angle D by my given. So again, go through my written given statements. If E is the midpoint of AD, this is segment AD, and so I would know that the two sides that, or two segments that make up that big segment are going to be equal. So AE and ED are equal. So AE is equal to ED by, again, use the same words. They use midpoint, so I'm going to say definition of midpoint. Right now, and then on my given statement, I have angle A is equal to angle D. So I've got two things equal. I've got angle A and D. I've got AE and ED, so I just need one more thing so I can look at my picture. When I look at my picture, it looks like a bow tie again, so I can say that these two angles are equal by vertical angle theorem. So the third thing that I can say is that angle AEB is equal to angle CED by vertical angle theorem. So again, just by looking at my picture, these are the two angles that I have equal. And then this is the side. The side is between the two angles. And so I can say that triangle AEB is equal to triangle DEC. by angle side angle, because the side is between the two angles that are equal. The next one that we have, the last one today, is going to be angle angle side. And so angle angle side is going to be two angles and a side, and this one the side is not between the angles. So with this one I have angle, angle, and this is the side. Again, if I'm just kind of looking at it, the side is not between the two angles, so this would be an example of angle angle side rather than angle side angle. This one, the side is not between the two angles. So with my, flip over to the back of the notes. Again, with my first step, I've got my given angle E is equal to angle V, and I have RN is perpendicular to EV. So my given statements. And so angle E and V are equal to each other, so I got a single line through each one of those. It says that RN and EV are perpendicular to each other. So these two segments are perpendicular to each other. Again, perpendicular means that they're right angles. So I know that these guys are both going to end up being right angles. So if they're both right angles, that means they're both equal to each other. So I can call them angle ENR is equal to angle VNR. ENR and VNR. So I know that they're perpendicular. Again, I want to use the same words that they use in the given statement. So since it says perpendicular, I'm going to say definition of perpendicular. It's kind of a shortcut again. Probably the way that would be the perfect way of saying it is to say because they're perpendicular, that means they're right angles. Since they're right angles, they're equal to 90, so they're equal to each other. But we can say that we know that they're both right angles, so because they're perpendicular, so they're equal. Once I'm here, so I've got two angles, and then I should be able to look at this picture. I've used all my written given statements, so that's why I look at my picture. It doesn't look like a bow tie, doesn't look like an hourglass, so I should have a side between it. So RN is the side that's shared between the left and the right triangle. So RN is equal to RN by reflexive property. And so again, I've got three things that are equal. I've got an angle, and then a side. And so I want to be able to see whether it's angle side angle or angle angle side. So again, just look at one of the triangles. Here's an angle, and then this is my side. So I should be able to kind of look at that and see that the side's not in between the two angles. And so this one is going to be an example of angle angle side. So triangle ENR is equal to triangle VNR by angle angle side. The side is not between the angles, so that's why it's angle angle side. And then the last one, again, M is the midpoint of QT. Angle X and angle R are right angles. There's my given statement. And so again, I can go through these. M is the midpoint of QT. So I can look at QT, know that M breaks it in half, so I can say that QM is equal to MT. Again, I'm going to use the same word. Since they said midpoint, I'm going to use definition of midpoint. This is my second given statement. X and R are both right angles. So if I know that X and R are both right angles, I know that they're going to be equal to each other. So angle X is equal to angle R. And again, I'm going to use the same words, so definition of right angles. I've got two things equal, so I just need to find a third. So looking at my picture, I can see that it looks like an hourglass, so I'm going to have vertical angles. Again, name them like I draw them with the vertex in the middle. So angle XMQ is equal to angle TMR by vertical angle theorem. There's my third thing that's equal. And so with my fifth step, I can say that triangle QMX is equal to triangle TMR. Again, when I look at this, I'll look at one of the triangles, this angle, and this is the side. And so the side is not between the two angles. And so I know that this is an example of angle, angle, side.